Hi ladies. So today what we're going to be doing is we're going to be covering 13.5. The plan is that I'm going to go through all of the notes for 13.5 during this video. And then on Monday, we are going to continue to go over 13.5, but we're just basically going to have some work time and some question and answer time. So 13.5 is all about solving trig equations. So we're going to kind of look at how can we actually go about solving some of these equations using our unit circle. So you'll want to have a unit circle out. And then also some of the identities that we've been learning so far. So this is an example of an equation that we're going to solve. Notice that this is over specifically a given interval from 0 to 180 degrees. So all of our answers we only want to have in that range from 0 to 180 degrees. So what we're going to do is I'm going to list some steps over here. So step 1 is I want you to get theta onto one side. Step 2 is we are going to put this into either sine or cosine. Now this may not be a step that we always have to use, but it's a good strategy. So like for example, you wouldn't want to have both sine and cosine in an equation if you can avoid it. It's not always possible to get rid of that, but if you can, sometimes it's helpful to put this into sine or cosine. Okay, step 3, sorry, my handwriting is really bad on this, is to factor. And step 4 is to set each factor equal to 0. Now, again, you may not always have to do all of these steps, but those are kind of the basic steps to solving these. So here we go. We are going to go ahead and work on solving 2 times the cosine squared x, or theta, minus 1 is equal to sine of theta. So I'm going to work to get theta all over to one side. So this would be 2 times the cosine squared theta minus sine of theta minus 1 is equal to 0. Now, here's what I notice. On this left-hand side, I have both cosine and sine, so I want to do something to change it so that it's all either cosine or sine. I don't know how to change sine into cosine, but I do know how to change cosine squared into sine. So that's what we're going to do is we are going to change cosine squared into sine. So this would be like 2 times, 2 times 1 minus sine squared theta minus sine of theta minus 1 equals 0. So now we can go ahead and multiply this out. So I'd have 2 minus 2 sine squared theta minus sine of theta minus 1 equals 0. And combining some like terms, I'm going to have negative 2 times the sine squared theta minus sine of theta plus 1 is equal to 0. And a little factoring hint, if you have something set equal to 0, I could divide everything by a negative or multiply everything by a negative to get rid of that negative. It's easier to factor when your squared term is positive, I think. You don't necessarily have to do this step. You would still end up with the same answer. Okay, so now we have essentially a quadratic. And just like we did in class in 13.2, it might be helpful for you to think of this as like 2x squared plus x minus 1 equals 0. And to factor using that, notice that I'm just kind of putting x in place of sine before I factor for sine. So I'm going to go ahead and try and factor this. I'd have 2x and x. equals 0. I could go ahead and say plus 1 minus 1. So now notice I'd have 2x times 1 gives me 2x minus x. So that would leave me with positive x. Remember, factoring never goes away. So my factorization here, I'm going to replace the x with the sign. So I'd have 2 times the sine of theta minus 1 times the sine of theta plus 1 equals 0. Again, this stuff in the blue here is just an extra strategy. You don't have to use it, but if you ever get stuck, it's something that can be helpful. Okay, I'm going to take us up here because now what do? Our next step, we factored. We're going to set each factor equal to 0, just like we would with any other equation. So we'd have the sine, or 2 times the sine of theta minus 1 should be equal to 0, or sine of theta plus 1 should be equal to 0. So for the 2 times the sine of theta minus 1 is equal to 0, I'd have 2 times the sine of theta is equal to positive 1, or the sine of theta is equal to 1/2. And over here on the left-hand side, or on the right-hand side, I have the sine of theta will be equal to -1. Now, if you recall back into chapter 12, what we did when we had situations like this was we said, okay, where is theta, where's the sine of theta equal to 1/2? Or where is the y value, remember sine on our unit circle, equal to 1/2? All of these things, for the most part, that I'm going to give to you guys are going to be values on your unit circle. You will be given a unit circle for the test so that you can actually solve these. So where is the sine of theta equal to 1/2? Well, if you look on your unit circle, that happens in 2 places. It happens at 30 degrees. It also happens at 150 degrees. Okay, where is the sine of theta equal to -1? Well, that happens at 270 degrees. All right, so these are all of our solutions to this equation. However, we have to be aware that we are looking for answers over a given interval. So we only want answers between 0 and 180 degrees, which means that 270 is not going to be a valid answer. So we would be looking at those 2 answers.
No, you're good.
All right, so the next question is kind of similar, except for I think this one actually has a little bit less work. Notice that all of theta is already on one side. It has both sine and cosine in it. However, we can't change any of these sines or cosines into the other one. So now we have to start looking at that factoring option. I notice that both terms have a cosine of theta in them. So I'm going to go ahead and try and factor out a cosine of theta. So I'd have cosine of theta times sine of theta minus 1/2 is equal to 0. Now, when I do this factoring, one of the goals should still be to make it so that your factors have only one trig function in it. So either sine or cosine or tangent for that matter, but we're going to primarily deal with sine and cosine. So if you have the cosine of theta, we could set that equal to 0 because that's one of our factors. And then we also have the sine of theta minus 1/2 equal to 0. So I'd have the cosine of theta equals 0. I don't have to do anything else with that. The sine of theta would equal 1/2, right? So the question is, where is the cosine of theta equal to 0? Well, I have a unit circle sitting right here next to me. So I'm going to look at all of the places where the x value on my unit circle is 0. So that would be at 90 degrees. And then also at 270 degrees. And where is the sine of theta equal to 1/2? So where's the y value equal to 1/2? Well, that's at 30 degrees. And then also at 150 degrees. Now notice that my interval says between 0 and 180 degrees. So this 270 we're going to knock out. So I'd have it at 30 degrees, 90 degrees, and 150 degrees. Your book will typically write them in numerical order. It doesn't matter your answers. I'm not picky about that. So if you were to write those as 90, 30, 150, that's fine. Okay, so in this scenario, we are going to be dealing with questions where we are asked to find all values of theta rather than just from 0 to 180, 0 to 360, 0 to 2 pi. We're going to have to deal with all values. And so if you recall back when we were dealing with coterminal angles back in chapter 12, we talked about the fact that this angle here has the same sine, cosine, and tangent value as that angle there. Okay, so we have to take into account all of those angles, and I'm going to show you how to deal with that. First, let's go ahead and start to solve this one using the same process that we did on the last one. So I'm going to bring all of our sine and cosine over to one side. So I'm going to have negative sine squared theta plus cosine of theta plus 1/4 equals 0. And then what I'm going to do is I'm going to say, okay, well, let's change this sine squared theta over to cosine so that I have just cosines or sines. So I'd have negative 1 minus cosine squared theta plus cosine of theta plus 1/4. That's using that Pythagorean identity. So this becomes negative 1 plus cosine squared theta plus cosine of theta plus 1/4 equals 0. Now here's a factoring tip. Because it's easier to factor without fractions, I always suggest that we clear our fractions if possible. So I'm going to multiply both sides by 4 to get rid of that fraction, and this will actually help us to factor. So this is negative 4 plus 4 times the cosine of squared theta plus 4 times the cosine of theta plus 1 is equal to 0. Okay, so I end up with 4 times the cosine squared theta plus 4 times the cosine of theta minus 3 equals 0. Now, we need to try and factor this, but that to me is pretty intimidating to factor. So let's go ahead and try and change this over just like we had done in the past. 4x squared plus 4x minus 3. This might be just a little bit more reasonable for us to look at to think about factoring, or at least less writing. So I'd have 2x and 2x. Let's try this, putting a 3 in here, and 1. So this would be 6x, and this would be 2x. Hey, I could make that 4x if I subtract the 2. So this needs to be minus, this needs to be plus. Okay. Okay, so that means that if I were to factor this, I'm going to come up here. If I were to factor this using kind of our normal information or cosine, I would have 2 times the cosine of theta minus 1 times 2 times the cosine of theta plus 3 is equal to 0. So set each of those factors equal to 0. So 2 times the cosine of theta minus 1 is equal to 0. And 2 times the cosine of theta plus 3 is equal to 0. So 2 times the cosine of theta is equal to 1. Or the cosine of theta is equal to 1/2. Okay, on the other side over here, I'd have 2 times the cosine of theta is equal to, that didn't read out, 2 times the cosine of theta is equal to negative 3, and the cosine of theta is equal to negative 3/2. So where do we go from here? Well, first of all, let's look at our unit circle and determine where is the cosine of theta equal to 1/2. Well, that happens at 60 degrees. And it also happens at 300 degrees. Okay. Now, where's the cosine of theta equal to -3/2? If you look on your unit circle, the x value is never equal to -3/2. This actually is undefined. This is not possible. And here's the reason why. If we think back to our graphs of sine and cosine graphs look something like this. Okay, the lowest value on this cosine of just a cosine of theta graph is -1. I would never get down here to -3/2. It's not possible on my graph of cosine. So this actually never happens where the cosine of theta is -3/2. Okay, so instead, I'm just going to focus on these two over here. But here's the deal. Not only does this angle happen at 60 degrees, it should be right about here, but this angle would also happen, or this cosine of theta would be 1/2 at 60 degrees plus 360. And then it would also happen at 60 degrees plus 360 plus 360. And then plus 360 again, and plus 360 again, and so on and so on and so on and so on and so on. All right, so you could go around the circle an infinite number of times. So how do we deal with that? How do we write that as our answer? Because we want all of these answers. We're going to have 60 degrees plus 360 times k, where k would be the number of times that you go around the circle. So 360 plus k, 300 degrees plus 360 times k. All right, so those would be my answers for this particular type of question for all values of theta. Okay, so here's another example of one with all values of theta. Go ahead and press pause and see if you can figure it out, and then come back and I will go through it with you. So for this one, we're going to start out by sine of theta is already all by itself, so we'll just divide both sides by 2. So I have the sine of theta is equal to -1. And then we just have to look at our unit circle and say, where's the sine of theta equal to -1? Well, that happens down at 270 degrees. And because I want for all values of theta, we'd add plus 360k. I apologize if you can hear my dog snoring. She's apparently very tired and very loud. All right. So, how about a question like this? Solve the equation. Okay, so sine of theta times cosine of theta equals cosine squared theta. And we're going to be looking over the interval of 0 to 2 pi, which means that we want this to be in radians. Okay, 0 to 2 pi in radians. So again, let's go ahead and get everything over to one side and see what we can do with this. So I have the sine of theta times the cosine of theta minus the cosine squared theta is equal to 0. Now, for a question like this one's a little bit different because I could change cosine squared theta into sine, but then I would still have a sine and a cosine in the term over here on the left-hand side. So I think maybe I need to take a different approach. One thing that I notice is that both of these have a cosine in common, so I might factor out a cosine. So I'd have cosine of theta equals, or times the sine of theta minus the cosine of theta is equal to 0. So now that I have this factored, let's set both factors equal to 0 and see what happens. So the cosine of theta has to equal 0, or sine of theta minus cosine of theta has to equal 0. So over here, the sine of theta minus cosine of theta has to equal 0. That means that the sine of theta has to equal the cosine of theta. Okay, so just because I had a term with both sine and cosine in it, I actually can still solve something like this. So where is the cosine of theta 0? Well, that happens in a couple of spots when the x value is 0. Okay, so where is the x value 0? That happens at 90 degrees Oh, but I don't want it in the degrees, do I? I want it in radians. So that's going to happen at pi over 2 radians. It's also going to happen at 3 pi over 2 radians. Okay, and where is the sine of theta equal to the cosine of theta? Well, that happens at pi over 4, where both the sine, the x, and the y values are root 2 over 2. It also happens at 5 pi over 4, where both the sine and the cosine are negative root 2 over 2. Those would be my answers. Notice that I don't need that plus. In this case, it would be 2 pi k. We don't need that numbers in there because we're on this interval from 0 to 2 pi. Here's another question where we have to be a little bit more creative with our methods for going about solving this. Notice that we're looking for an interval between 0 and 360. The problem is this, that cosine of theta I can't turn into sine of theta, and sine of theta on its own I can't turn into cosine of theta. So I need to be a little bit more creative. Here's an extra strategy that you might try. What if we were to square both sides of the equation? The reason that I'm doing this is because once I square both sides of an equation, I can turn cosine squared into sine squared, or I can turn sine squared into cosine squared. So this becomes on the left-hand side cosine squared theta. And on the right-hand side, when I square this, I have 1 minus sine of theta times 1 minus sine of theta. So this becomes 1 times 1 is 1, minus sine of theta minus sine of theta plus sine squared theta. Okay, now recognizing that I'm going to want to turn everything either over to sine and cosine, I notice that I have a lot of sines happening over here on the right-hand side. So let's go ahead and change cosine squared into sine. So this would be 1 minus sine squared theta is equal to 1 minus 2 times the sine of theta plus the sine of the squared theta. And now let's bring everything over to one side. So I'm going to subtract 1 from both sides. I'm also going to add sine squared theta. Now, I hope this is okay, but I'm going to go ahead and try and save myself a little bit of a step by reorganizing this as I write. So on my left-hand side, I now have 0. On my right-hand side, the 1 went away. I have a negative 2 sine of theta, and then I also have a positive 2 sine of theta. So I'm going to write sine squared theta. So I'm going to write this as 2 sine squared theta minus 2 sine of theta. Okay, well, how do we solve this? Let's factor. We don't want to divide everything by 2 times the sine of theta. We never want to divide by something with a variable if we can avoid it, because then that will eliminate an answer. We covered that back in, I believe, chapter 5. But in the meantime, what we can do is we can factor this out. So I'd have 0 equals, both of these have in common a 2 and a sine of theta. And then in the first term, I'd be left with sine of theta. In the second term, I'd be left with minus 1. So 2 times the sine of theta has to equal 0. And sine of theta minus 1 has to equal 0. So this would be the sine of theta has to equal 0. And the sine of theta has to equal 1. So where does that actually happen? Where is the y value equal to 0? Well, I would have that at 0 degrees and at 90 degrees, also at 360 degrees. Okay. And then where is the sine of theta equal to 1? That happens at 180 degrees. Just a note of something to be careful of. Up here, notice that we are not equal to 360 degrees. So this 360 degrees actually is not part of this solution. So I'd have 0 degrees, 90 degrees, and 180 degrees. Okay. All right, home stretch. Let's do these last ones. Okay. getting a little bit more complex. So solve tangent to the 4th power of theta minus 4 times the secant squared of theta is equal to -7. All right, here's what I'm going to do. I'm going to go ahead and change some of these things over. The thing that I know is the secant squared theta. I think I can change that to the tangent of theta. So if you recall, the tangent of theta, or sorry, tangent squared theta, plus 1 is equal to the secant squared theta. Okay, so I am going to go ahead and replace that. So I'd have tangent to the 4th of theta minus 4 times tangent squared theta plus 1 is equal to -7. And I'm going to go ahead and simplify this a little bit more. So the tangent to the 4th power of theta minus 4 tangent squared theta minus 4 is equal to -7. And if I add 7 to both sides, set this equal to 0, tangent to the 4th power of theta minus 4 times the tangent squared theta is plus 3 is equal to 0. All right, so from here we can factor. Again, a lot to look at. I might go ahead and plug in x to the 4th minus 4x squared plus 3 equals 0. Back when we were factoring things like this, we did some work with U substitution. That's an option here, but you might also be able to think about this. If I have x to the 4th, I'm going to want x squared and x squared as those first two pieces. And then I have 3, so I'd have 3 and 1. Both of them have to be negative to make this -x squared and minus 3x squared, which add up to equal -4x squared. So when I factor this using tangent, this would become tangent squared theta minus 3 times tangent squared theta minus 1 is equal to 0. So let's simplify this. The tangent squared theta minus 3 should equal 0, and the tangent squared theta minus 1 should equal 0. So the tangent squared theta should equal +3. Or if you take the square root of both sides, the tangent of theta is equal to plus or minus the square root of 3. On the right-hand side, the tangent squared theta is equal to 1, or if I take the square root of both sides, the tangent of theta would be equal to plus or minus 1. Okay, so coming up here, we need to figure out where this is true. So where is the tangent of theta equal to √3? Well, here's the deal. We kind of have to go back to figuring out tangents. Remember, the tangent of theta is equal to y over x. And I know that I want there to be a √3 in here. So I know that the two values for my unit circle that I'm going to use are √3 over 2 and then also 1/2. So the question is, which one of these is y and which one of them is x? Okay, so I'm just going to go ahead and test one out. Because √3 is in the numerator, I'm going to put √3 in the numerator. So I'd have √3 over 2 divided by 1/2, which means that this would be √3 over 2 times 2 over 1. And notice the 2's would cancel out, so this is equal to √3, which is what I want ultimately. So my y value has to be √3 over 2. My x value has to be 1/2. So I'm going to go ahead and pull up my unit circle, and I'm going to look at it and say, okay, where is y √3 over 2, and where is x 1/2? Well, that happens first at 60 degrees. Okay, so that happens first at 60 degrees. Okay, And then keep in mind that this is able to be plus or minus root 3. So really, in reality, I want all combinations of positives and negatives. Anywhere where the y is either plus or minus root 3 over 2 and plus or minus 1/2. So that also happens, this happens at 60 degrees. This also happens at 120 degrees. It also happens at 240 degrees. And then it also happens at 300 degrees. Okay, now because I am asking for all values of theta, we also want to have that plus 360K. All right, so this was just the first part. This was just the tangent of theta is equal to plus or minus root 3. The second piece was the tangent of theta. Do this in purple. The tangent of theta is equal to plus or minus 1. Now, where is my tangent equal to plus or minus 1? Well, that happens anytime that the sine and the cosine are the same, because tangent is equal to sine over cosine, or anytime that the y and the x are the same. So that's going to happen at 45 degrees. It happens at 135 degrees. It happens at 225 degrees. And then it also happens at 315 degrees. Oops, not 3,150. Got a little circle happy there. Okay, again though, we have to add plus 360K. Okay, now, so this theoretically is our answer. Okay, it happens in a lot of different spots. However, your textbook is going to give you a different answer. Your textbook is going to give you an answer recognizing that the period of tangent is 180 degrees, or it's just pi units. All right, so if you look at your unit circle, directly across from 60 degrees, you will find 240 degrees. And directly across from 120 degrees, you will find 300 degrees. Directly across from 45 degrees, you will spot 225, and directly across from 135, you're going to spot 315. So what does that mean? That means that those values actually repeat themselves every 180 degrees, or every pi units. So another way to write this would be 60 degrees plus 180K. And when I write that, that covers these two. That covers 60 degrees plus 240, because when I add 180, I get 240. Then when I add 180, I get a coterminal angle with 60. Then when I add 180 again, I get a coterminal angle with 240, and I just keep going around. I would need to have 120 degrees plus 180K. I would have 45 degrees plus 180K. And then I'd also have 135 degrees plus 180K. All right, so this would also be a way to write the answer. This is actually how your book would write it. I'm okay with you writing it either way. So long as you have all of those answers taken into account, I'm not picky about it by any means. But like I said, your textbook might write it with fewer values. Check what they're adding though, because if it's adding a smaller number, that's probably why they're adding fewer values. Okay, last question. Go ahead and press pause. Use everything that we talked about so far. This has sine. It's very similar to the last question. And go ahead and give this one a shot. All right, so for this one, I'm going to go ahead and bring everything over. So I have sine to the 4th power of theta minus 2 times the sine squared theta plus 1 is equal to 0. And I'm going to go ahead and try and factor this. I'm going to use that same strategy, x to the 4th minus 2x squared plus 1 is equal to 0. So I would end up factoring this as x squared and x squared, 1 and 1. Both of those are subtraction. So when I change this back over to signs, I'd have sine squared theta minus 1 times sine squared theta minus 1 is equal to 0. Or sine squared theta minus 1 is equal to 0. And really, the other factor is just going to end up giving me the same answers. Okay, so I have sine squared theta is equal to 1. So if I take the square root of both sides, the sine of theta is equal to plus or minus 1. Take the square root of both sides. Okay, well, where is the sine of theta equal to plus or minus 1? Well, let's look at our unit circle. Where is the y value equal to positive or negative 1? That happens at 90 degrees. It also happens at 270 degrees. Okay, because it says for all values, we want to add that plus 360, okay, and plus 360k. Just as a side note, we could also write this in radians, just to show you how to do that. This would be at pi over 2 plus 2 pi k. 2 pi is the same as 360. And then at 3 pi over 2 plus 2 pi k. All right, so either of those answers would be a perfectly acceptable answer. All right, so today what we're doing is we're just doing a lot of solving. Notice that there's a lot of factoring involved, so always be kind of on the lookout. If there's an opportunity to factor, you might want to do that. Here is the homework assignment. You can use the remainder of class, which isn't a lot of time, but there should still be some time that you can get started on this. Our assignment won't be due until Tuesday, the 7th. On Monday, we will have some time that I can answer questions and we can be working on the assignment. So I'd suggest that you at least start on it so that you come to class on Monday with some extra questions. All right, thanks for watching the video, and I will see you on Monday. Have a great weekend. Bye-bye.